Welcome to Cloud-Based Bedtime Stories with Aaron Wanjala. You made it through the day. Get comfortable, close your eyes, and let tonight's story find you. Nothing is paging, we can just read. Tonight we journey into the heart of a vast and calm archive, a digital library designed to hold immense volumes of structured information, allowing us to ask large questions and receive answers in a single peaceful breath. This is the story of BigQuery. Chapter 1: The Separation of Duties. In traditional databases, the work of storing data and the work of analyzing it are often done in the exact same space, using the same physical resources. Scribes and scholars must share the same narrow desks. When many scholars arrive to ask complex questions, the scribes find their writing slowed. When new records are written in volume, the scholars must wait. BigQuery is designed around a different principle. It separates these two tasks completely. There is a storage layer whose sole job is to receive, organize, and preserve data, and there is a compute layer containing a distributed engine whose sole job is to execute queries. Between these two layers lies a network of immense capacity, a petabit-scale network that allows data to travel from storage to compute in a fraction of a second. Because these layers are independent, they do not compete for the same memory or processors. The storage layer can grow larger and larger, holding petabytes of information, while the compute layer remains still. When a query is made, the compute engine dynamically allocates the exact resources needed to answer it, then returns those resources to the shared pool when the task is complete. There are no servers to provision, no virtual machines to manage, and no physical hard drives to configure. The system balances itself, allowing engineers and analysts to focus entirely on their data. Chapter 2: The Columns and the Rows. Inside the storage layer, data is organized in a way that differs from traditional systems. Many databases store data in rows, writing a complete record from left to right before starting the next. This works well when you need to look up a single record at a time. But when you want to analyze trends across millions of records, reading row by row means reading a vast amount of unnecessary information. BigQuery stores data in columns. Every entry in a column is stored together. If a query asks for the values in a single column, the engine reads that column and ignores the rest of the table. This drastically reduces the amount of data that must be read from storage, allowing queries that span terabytes to finish in seconds. The primary container for this data is a dataset. Inside a dataset, data is organized into tables and views. To keep this information safe, the storage layer automatically replicates the data across multiple physical locations. If one data center experiences a pause, the system automatically serves requests from another location, maintaining high availability without any manual intervention. Data can enter this library in two ways. It can be loaded in batches from files stored in formats like Parquet, Avro, or JSON, or it can be streamed continuously, record by record, using the Storage Write API, allowing the library to stay up to date in real time. Chapter 3: Asking the Questions. To find meaning in these vast columns of data, we use standard SQL. It is a familiar, descriptive language that lets us describe the answer we want, rather than the step-by-step instructions on how to retrieve it. For those who work in Python, BigQuery Data Frames provides a way to interact with the data using a Pandas-compatible interface, a popular tool among data scientists. Sometimes the information we need does not live inside BigQuery at all. It might reside in external systems, like spreadsheets in Google Drive, files in cloud storage, or transactional databases like Spanner or Bigtable. Rather than copying this data over, BigQuery can perform federated queries. It reaches out across the network, queries the data where it currently lives, and brings back the results as if it were all stored in one place. That's all for this journey through the cloud. Wherever your clusters reside tonight, may they remain stable, resilient, and peaceful. Until next time, sleep tight until you have to serve your next request.